Hi there, I'm Phil from PicoKit. Today we're going to look at how to create a clock on the display. You'll see here I've got minutes ticking away. Now one thing, that we're not doing a real-time clock, but more of a simulated clock. So essentially, if you were doing a project, you might want to do your testing in a faster time scale than standard time. So if you wanted something to trigger at say 5 p.m. in the afternoon, you don't actually want to wait till it gets to 5 p.m. So if we can simulate a clock on our Intelli-LCD from PicoKit, then that will give us a much better outcome. Now what we're going to look at today also is the difference between 8 bits, 9 bits, 10 bits, 20 and 30-bit values. Okay, now importantly, our clock that we're sending, the numbers that we'll send, 1 to 12 and 0 to 59, are in this range of 10 bits. So we don't have to worry about 20 or 30, that's fine. But we'll have a look at what the difference is if we send an 8-bit versus a 10-bit, as well as looking at the standard, how do we clear the display, how do we turn the cursor on and off, and things like that that you might use in a clock. So first of all, we want to make sure that we have the 14-pin analog microchip, and that will give us all the settings that we want for our tools. We're going to start with our comms tool, which is this blue one down here with the RS-232 port on it. We're actually using Manchester encoded signal, which means we're sending clock and data through one wire, which is the yellow wire, and the Intelli-LCD knows exactly what to do, which is good. Let's transmit a literal. So this time we'll send a literal 8-bit, and we'll send the literal 8-bit 76. And on C0, and so let's just see what that does for us. Oh, we got the letter L. So a capital L actually has the character, ASCII character number value of 76. So 76 in ASCII is the capital L. Oh look, we can see that. So if you send the number 76 as an 8-bit value, it's going to, on the Intelli-LCD, say, oh, let's create a character. And in that way, you could send lots of different values, and it would print the alphabet, essentially, and the different characters within ASCII. You could send all 255, although you'd only see 2 by 16 on the display at any one point in time. Now, what we want to do, though, we want to see the number 76. We would actually send a 10-bit value, and the Intelli-LCD knows that when it receives 10 bits of information, it's meant to display 7 as a character and 6 as a character. So let's do that. We'll click OK and program, and we get the number 76. So that's the difference between having a 10-bit and having a 8-bit value. Now if you did a 9-bit, it's going to be different again, because it's going to interpret that value 76 as control information that should change the settings and stuff. So we don't want to muck around with that because we don't know what that's going to change. Okay, so leave it as a 10-bit, and we might want to go up here and we'll just call it values. Okay, that's fine, and they're actually numerical values. Now, one thing we might want to do is clear the display. So if we do the control code number 1, what I mean there, control code just means we need a 9-bit value. And if we make it the number 1 and we send it on C0, that will have the effect of clearing the display. So we'll do that. We'll link it up with our link lines into our alpha code. And let's program. And so now we should clear the display and write the number 76. That's what we want. Now, essentially, values when they're written are just constants. Yeah, that 76 can't be changed in code if we send it as a literal. It's Just means, oh, if you want a number on the screen, that's the easy way to do it. If you want the number to change, like a variable, then we actually have to choose data. And what this means is we're going to choose in here 10 bits of information. And you could just choose GPR1F, but you might run into problems because we actually want to send first the low bytes of information. But the GPR1F, that's going to be our data high value. And we're actually only going to send 2 bits of that data. But we start by sending our low byte. So that's the one we want selected, data low. And data high is just sitting there at the moment, but it will use 8 bits of data low and 2 bits of data high, and it will send them all over pin C0 to the Intelli-LCD. So instead of values, we're going to call it data now. Now what data is it going to send? Well, I don't know what's in those values, so let's program it and see if there's anything in there. Oh, look, we've got the number 771. Now, what I can say there is it means data high has a number in it, and so does data low, because it's giving us a number bigger than 255, and that means that we need to actually reset or set 2 different bytes. So the first one, data high, all of our numbers are going to be under 255, so I'm just going to make data high 0. That's easy, and then we'll see what it does. Data high equals 0. Let's put that in our code. And align those. Okay, so we had 771. If we program again, now we've got the number 3. So data low just has the number 3 in it. Well, let's see if we can change that number. So we'll copy that one. Now, if your text is taking up most of that, I'll just give you a tip. You can move your cursor to the edge of the tool. See, if I go to the middle, I'm typing in the middle. But if you want to select it, click it on the edge, Control C, Control V, and we can click and drag to move it as well. Or you can just create another one. We're going to change that to data low, and we might just give it a number like 100. Okay, but we have to go into the tool, and we actually have to set that number. For the moment, it's still a literal, but we're loading the literal into data low. So we need to make sure that we also select data low, and that will then display the data low on the Intelli-LCD. There we go. So we're using our data registers now, which is a little bit more usable. It means that any number that we update in this low byte will be displayed on our screen. So let's do that. First of all, there's one other thing that your LCD might have. If you have a flashing cursor, that's something that we can turn off, and that's in that's another control code. So if we copy the clear output, then we can change that. Instead of transmitting the number 1, we can transmit the number 12, and 12 is a special number that is going to turn the cursor off. And you can get that from the table that we looked at earlier. Okay, so the number 12 is this visibility options. The number 8 plus 4 gives us the number 12, and that's saying turn the display on. If we had the number 14, it would turn the display on and the cursor on. And if we had the number 15, it would also blink the cursor. So if we just send the number 12, it will turn the cursor off and it won't blink. So let's put that in our code. And in fact, we'll put that at the start because we only need to do that once. Now we're not going to see anything different here because I don't have the cursor on. So just to have a look at that, let's change the number to 15 and program. And we should get the blinking cursor, which we do. And if we try that with the number 14, the cursor should stay, but the blinking should stop, as it does. And if we go back to the number 12, we'll get the desired outcome with the cursor turned off. There it is. Okay, now we've got everything displaying correctly there, which means we can start looking at how to count this number. We actually want to get rid of the stop tool, and we want to put that in a bit of a loop. Okay, so this is the sort of process we'll be clearing the display, updating the data, or sending the value to the display, changing the number, clearing the display, sending the value, and doing that over and over. So so let's have a look. It really doesn't matter if that clear is before or after, and we'll actually find that it works better after, because we'll be updating both the minutes and the hours, and sending 2 packets of data. And even if we put the colon in between the minutes and the hours, that will be good for us. So let's have a look at updating the actual value. So we're going to do that with a counter. Now this counter basically will take a byte and will be changing the number within that variable value. So if we were going to do minutes, so data low is the register that we're changing. So if we call that minutes in there, then we're going to change, and we're going to have start, the initial is 0, the step, maybe if we do 15, and the upper as 59, because we actually go up to 59 minutes and then back to 0. And we're going to reset back at 0. That's fine. So we're selecting minutes now, and that means actually if we annotate that, just put in mins, keep it nice and short, easier to select. So instead of leaving this as a file register, we're just going to replace it with our counter tool. Now that's going to update very quickly. We actually want to slow it down a bit. So we're going to put in another process tool. This process will be our 1 second timer or delay. And that means it will hold the display for 1 second and then it will go and update. So let's do that. Align those and program. Well, it started at 15, which is interesting, but that's okay. 15, 30, 45. Oh, yes, of course. We're counting in 15. So even though it starts at 0, it means over here at the start at 0, by the time it gets to the counter, it's already adding 15 and then going and displaying. So if you actually wanted it to start at 0, you would put the counter after the first time it comes through. Okay, so I can show you that. Control X, Control V. So in the same way, we'll connect that up. So we're coming in to clear the display, and then we'll repeat like that. So let's program. It should start at 0 this time. 0, there it is. 45, and then back to 0. And so you could change your increment in minutes. You could say, oh, well, we actually want to go up 1 minute at a time. So instead of stepping at 15, we'll see that count from 0, and then it's just counting up 1 at a time. Or if you wanted to go up 10 minutes at a time, then we could put in the step size of 10. There it is. Okay, so that's giving us our simulated minute value, and you can have it incrementing however you want. Mind you, it would have to be a factor of 60 because you want it to roll over accurately. So you wouldn't choose numbers like 7 Okay, but you could choose 3. 4 is a factor of 65 is, 6 is. A lot of numbers are factors of 60, okay? Even like 12, 10, 12, 15, all of those, 20, lots of them. Okay, so choose a number that's a factor, and that will be your step size in the minute. So now what we want to do also is we want to have an hours counter. So we're going to do that in the same way. We're going to have a second data high, which we're not going to use. So data high 2, we'll call it. And so in here, we're going to call this hours. Our initial is going to be, let's just start at 1. I can't think of that in my head. Okay, so we'll start at 1 and we'll go up to 12. And then we'll reset at 1. Importantly, we're not going back to 0. You could make this a 24-hour clock. That would be fine. We could go reset at 24. I'm just going to do 12 just because it will go through twice as fast. So we annotate that as hours, or even HRS, hours. That's fine. Okay, now do we want to update the hours every single time we update the minutes? And I suggest we don't. I think what we need to do here is work out a way of only updating the hours once it gets to the last values. Okay, when it equals 0, it means it has rolled over the minutes. So let's do that. We'll put in a decision. This is a compare tool. So the compare tool is good for testing bits of information or testing actual values of information. So we can choose a file test, and we can choose a value. You can have a file-to-file comparison, or we can have a file to value comparison. So we're going to say, oh, if it equals 0, and which number? Well, we go to the direct tab and we say the minutes. If the minutes equals 0, then we should really update the hours because it's just rolled past. Of course, we're going to come into the decision. So true, it is 0. We're going to update there. False, it isn't. We're going to go and send our values to the display. Well, we're going to clear the display. Mind you, we can also send hours to the display. But well, at the moment, we're still just sending the minutes. So let's call this one minutes. And we'll just program that and see how it goes. It should still count the minutes for us. We're not actually displaying the hours. So what do we want to do? We want to have another one of these outputs, but this time we want to display the hours. So let's change that. Transmit. We're going to select hours. And that's fine. Actually, on the display, we can also put hours. And in a clock, you would normally have the hours before the minutes. So let's move those along a bit. We'll put the hours and then the minutes. It doesn't really matter which way they're updated. In the counter, you know, you can update the minutes before the hours as long as you display the hours before the minutes in a clock display. So let's do that and program. Okay, so we've got 1, 0. Looks a bit odd when we don't have that colon in between. So that's the last step. Let's use another comms tool, and this time we'll go back to using a text, which is the easiest way to get a colon. We just type it colon, and we'll put that in between the hours and the minutes. Like so. Now I'm going to put my false on top on this one. Just go false on top just to make it so that those arrows aren't overlapping. And I'll move that to the top. That looks a bit better. Okay, let's program that. There we go. So we're going up in 10 minutes at a time. It gets to 40, 50, and then 0, 20. So that's incrementing the hours at the correct time when the minutes reset to 0. Okay, so the last thing we need to do there is annotate. This should be a colon. And this one here is our decision. So minutes equals 0 and question mark. So do the minutes equal 0? That's the decision. Yes, they do. Oh, go and increment the hours. No, they don't equal 0. They equal something else like 10 or 20 or 50 or whatever. Then don't increment the hours. And so we're still displaying the existing hours. Whether we increment it or not, we still have to display it. So that is how to do a clock using the Intelli-LCD and PicoFlow ALPHA. Thanks for watching.